He's a civil engineer with more than 25 years of experience in improving engineering education and has published many papers on problem and project-based learning and the use of online technology to support student-centered learning, and was instrumental in the introduction of project-based curriculum in civil engineering at Monash and in several disciplines at RMIT. He's also worked in sustainability and has been involved in startup companies in that area. So to today's theme of the UN Sustainable Development Goals and social responsibility, I think this is an excellent way to start the session off. So Roger, over to you.
Thanks, John. And so you should see my slides now. And thanks for the opportunity. So I've titled this Social Responsibility in a Time of Change. And really, I want to take a bit of a change theme to the idea. And when I look at the very distinguished audience that we have, I think it's going to be hard to impress any of you. So what I think I'll try to do is give you a bit of a sense of what we've been doing at UTS, University of Technology in Sydney, in not only in terms of sustainable development goals, but in curriculum change in general. So one of the key drivers, of course, is the future of work, and the things that we're hearing about are that we need to prepare our graduates for more complex problem solving. The pandemic, of course, is really thrown that in our faces. And I took that picture there in Hyderabad, I think, a couple of years ago, thinking, well, as a civil engineer, here I am, I've landed in a job. This is the task I've been ordered to do, is to try and sort out the traffic problems. I don't think that's an easy thing to teach at a university, but we need to give students much more opportunity to grapple with complexity of that kind. We also have transformative technology such as the Internet of Things and so on, which have just changing the kinds of solutions that are available to all of us. And then, what we're seeing is that everyone wants to innovate. We've got much quicker marketplaces. How do we prepare students for that? Well, we used to have a globalized world. It's not quite as globalized as it used to be temporarily. And we need to prepare graduates for multidisciplinary and multicultural workplaces. And of course, collaboration and communication are really at the heart of engineering. So when we then look at the Sustainable Development Goals, and we can think, well, where are the ones where engineering plays a part? And I've put some circles around the really obvious ones, like clean water and sanitation and affordable energy and responsible consumption and production, industry, infrastructure, sustainable cities, and so on. But I'm sure you'll see that engineering plays a big part in many of the others. In fact, many of the ones circled are enablers for dealing with poverty and hunger and gender equality and all sorts of other things. Maybe I could have put one around good health and well-being for the biomedical engineers. So we've got this fantastic array of challenging problems. And I think that we've got young people coming into our universities who really want to do something about it. And what they're faced with are fairly traditional engineering programs. One of the activities that's underway at the moment, the Australian Council of Engineering Deans is leading, which they call the Engineering 2035 project. It has done some preliminary analysis and produced rather similar outcomes, which says we need to prepare our engineers for a much stronger societal focus. Again, to deal with complex real world scenarios. We need much stronger engagement with industry and the community. And then we have the benefit of these fantastic new digital tools and digital twins. And I've watched some webinars recently where big engineering projects, big bridge projects, and so on are being completely constructed in the virtual world first, and then constructed a second time in the real world. So that technology is moving so quickly at the moment, in the last five years in particular. And then, of course, we have the support of online learning, which I must admit never seems to progress as quickly as I would like it to. But what we're all faced with at our own universities is trying to change curriculum, because we've got lots and lots of learned colleagues who say, no, you know, it all just has to be done the way it has been done for the last 30 years. So how do we go about changing our curricula? And indeed, why do we teach as we do, and how might we do it differently? So many of you have probably seen this picture, which I think dates from about the 14th century. And I must admit, you know, if you took somebody out of that picture and brought them into one of our lecture halls, they wouldn't be too terribly surprised. And yet, you know, the whole idea of a lecture seems to be completely embedded in our minds as the way that we do education. It's this kind of medieval idea that you know, the words must be spoken from the book so that the students can write them down. And in an age where we all have the world's knowledge base in our pockets, it's a kind of a crazy idea. And I love this quote by Murray Gell-Mann, who said, you know, modern education is like being taken to the world's greatest restaurant and being forced to eat the menu. And I must admit, I was reviewing one of our subjects here at the university just the other day, and it was a really interesting topic. And my summary of it was, but wow, you know, the design of the subject just made the whole topic really dull because of the way the assessment had been designed. And I think unfortunately we do that too often. We take really interesting bodies of knowledge and turn them into dull pieces of assessment. But what we do know that works is active learning, and you've probably read the papers by Michael Prince and Richard Felder to that effect, which is now more than 15 years old. And here we are still talking about something we should do. So one of the things that has been very successful in Australia has been, in first year, is to engage students in the Engineers Without Borders Challenge. And that's where students really meet sustainability and societal focus for the first time. And I think the EWB challenge has moved into other parts of the world. No, I think in the UK and New Zealand and maybe elsewhere. But it's always a really nice project. It gives first year students an opportunity to think about life in another country, you know, how life is lived and how engineering might benefit them from a point of view of clean water, sanitation, energy, telecommunications, transport, all sorts of things. But in that process, I must admit that many students come to university and they think that, you know, somehow we're just pulling their legs, oh, but, you know, why are you teaching all this stuff to us? You know, we just need more maths and physics. Isn't that what engineering is all about? So it's a bit of a process of trying to change the indoctrination they've had in their first 12 years of schooling. So what we're trying to do then is to really create the key principles for student learning experiences for active learning. So, you know, we start with challenging ideas. We want active engagement, students work in groups to develop their ideas. We try to provide a supportive environment. We've got active real world learning happening, and it's collaborative and reflective. And the key ideas that came out of tomorrow's professor article that you might like to look up. And I think my favorite educational quote of all time is this one by Thomas Schul, who said, the teacher's fundamental task is to get students to engage in learning activities. And you'd have to think that, you know, the teacher's fundamental task is often, oh, but I need to give lectures. No, you need to engage them in learning activities. And as you can see, this is not a recent quote. So how do we do that at UTS? Well, we do it through studios, which I think of as problem-based learning 2.0. And what's a studio? Well, like problem-based learning or project-based learning, it starts with a challenging scenario, very often from industry, something that has multiple solutions. Students, of course, work in teams. They use the latest computing tools. It relies on students learning the fundamentals, some beforehand, some when they're on the job, because they get into a studio and they discover that they need to learn some new skills, and that's when they'll have to engage in that learning. Students develop a learning contract because different students in the studio are doing different things. Not everybody is going to come out with exactly the same learning outcomes. And they demonstrate their achievement through a portfolio, which is an accumulation of learning, or effectively like a design journal. So in this process of change, we've kind of grappled with how do we make this happen? So we're a faculty of about 12,000 students, maybe 8,000 of those are undergraduates. So we've got some quite big schools. Civil and mechanical are really quite big schools, 300 or 400 students in each year. Some smaller schools like data engineering and electronic engineering and so on. And we've had to look at, well, who's providing the leadership in this process? And we've been lucky to have a dean who's given quite unambiguous leadership that this whole idea of embedding studios in our programs would be a key development. The heads of school, I think, have been somewhat less important in that role. We've had an associate dean, we have deputy heads of school. So you can see that there's a whole range of people who need to be involved. And I'm sure that you have similar people in your own faculty who are constantly working to make the kind of change happen, to produce the kind of graduates that we need. And last but not least are students, because when we started to do summer studios, which I'll tell you a bit more about shortly, it was the students who set up to lead some of those studios, and I'll tell you about that soon. So if we go to, if you remember Ruth Graham's report from 2012, Achieving Excellence in Engineering Education, the Ingredients of Successful Change. So she really reviewed, no doubt, many of your programs and looked for, well, what are the success factors and what makes it work, what makes it fail. And like a lot of the change literature, it says, well, there's always a good crisis is always helpful. It's falling enrollments or maybe changing industry segments, all sorts of things, global pandemics. And then what she noticed was that people need to be ambitious and to aim high, and that really helps. And that's where people like heads of school and deans are absolutely critical in setting that agenda. And then she said, well, and then of course the academic engagement work is critical, and you need to work with the willing and don't waste your energy on the unwilling, because maybe they'll come around eventually. The team teaching is an absolutely critical part of success, but nevertheless, some of those innovations are not sustained, and I'm sure that we can all think of ones that at our own institutions that haven't lived on after key personnel leave. So I was going to tell you about summer studios, and this turned out to be a key innovation at UTS for making change happen. And this is where we've also been able to integrate the Sustainable Development Goals in the process. And we did it because we wanted to, as much as anything, to give students an exposure to a different way of learning. And we turned out that the exposure of the academics was just as critical. And several of the academics who've come in, run summer studios, have gone on then to innovate in their own subjects in other semesters. And this subject runs as an elective, and we've had about 150, 160 students for each of the last 3 summers who've been involved in the subject. But I mentioned the student-led studios and these are some of them. So we had a humanitarian engineering studio the first year. We had activating a smart city, combating the heat island effect in the central business district. We've had computer vision, machine learning. We've got the Vivid light show, which is the picture that you see there. The guys were designing a visual display for Vivid, which is a nighttime light show in Sydney, usually around Easter time. There was the Space Challenge, Internet of Things, robotics, cybersecurity. So students, so either senior students or recent graduates are the ones who stepped up to lead these particular studios with just absolutely outstanding effect. And the way these studios run is we have 5 learning objectives, which are basically our 5 key graduate attributes, which is they need to be able to engage with stakeholders to identify problems, to see the problem in its social context, applied design thinking, systems engineering, those kinds of ideas. They need to be able to demonstrate technical skills. They need to work collaboratively with tools and also conduct self-peer and team reflection. And with those 5 general purpose learning objectives, we were able to deal with lots of different topics in that way. Most of you have probably seen design thinking, so I can skip over this pretty quickly. But it's a nice, simple framework for students who haven't done this kind of work before to just begin to work their way into problems. They're a bit beyond the kinds of textbook problems I've seen before. One of the things that we have used over each of the summers is we borrowed some ideas from Agile project management. So this subject runs over an intensive 6-week period. And we broke it up into 4 segments as problem definition, exploration of solutions, prototype design, and then kind of project completion and prototype refinement, if you like. So it's what we call the Mida Summer Studio, and Mida stands for More Innovative Design Able Students. And Midas came about because we were playing with the idea of we want a gold standard, and we thought, well, you know, what's gold? Well, it's, you know, we've got well, Midas was the king who, you know, everything touched turned to gold, and so then we turned it into an acronym, which we were really quite pleased about. But the Agile idea means that students are constantly managed effectively to the successful conclusion. So they do their first sprint, which is all around problem definition. They meet about every 2 or 3 days, and then they produce, if you like, a first submission. Then they develop some solutions and so on. I'm sure you've done something similar in your own programs. And the first time we ran this, students were quite delighted at this you know, refreshing approach to how to learn. And this particular student commented they really enjoyed the open-ended scope, freedom, creativity, and the ability to work from their own practical experiences instead of a regimented assessment schedule. So, you know, if you're going to then integrate this, because at the moment this subject is an elective, but what if we're going to do more of these things, and I'll show you the mechanical program in a moment, then how do you remake a traditional curriculum? And I think sometimes people need to start small and just try things out. And the easiest thing of all is just to put small projects into most subjects. So how do you work the SDGs into fluid mechanics? Because, you know, one of the SDGs is clean water. But then think of sequences. So we have sequences of subjects in, say, fluids and thermodynamics, or structures, or circuits, or whatever. Then also you can identify a project course in each semester. So no matter what happens, there's one subject in every semester where students are doing project work. Or you can share a project across the semester, and UCL's integrated engineering program works that way. And then, of course, you can combine bigger courses into bigger units with bolder objectives, which is kind of item number 5 here. So this is a sequence. Number 2, number 3 is projects in each semester. Number 4 is sharing a project across a whole semester. So one of the things we've done is with the end goal in mind of getting to these much broader, complex outcomes, we've been re-engineering our mechanical engineering curriculum, and we've basically broken it down into its 5 subdisciplines of kind of structures, machines, materials, manufacturing. Then there's kind of mechanical dynamics, vibrations, and so on, and thermofluids. And then basically said, well, okay, we're going to have this sequence of studios, these yellow subjects across here, and each subdiscipline will have 2 subjects in which to teach the fundamentals, and then that will get put into practice through the studio. So that's one of the jobs that we've been working on. So now what we're thinking about is how do we make these professional studios into the kinds of complex learning scenarios that we've been I talked about earlier in the presentation. So one of the things, just coming back to the Council of Engineering Deans 2035 project, is that the question is, can you get your academics to change? Do we have the right academics in our universities? So if we've done a survey, we've collected about 400 valid responses so far. And out of those, about 80% of the academics agree with the statement that substantial change will be necessary in the next few years. Only 65% of them report that their leadership team provides or demonstrates good practice. So that's something to think about if you're a head of school or a dean. Only 53% will actually emulate their leadership, which is a bit of a worry. And only 44% say their institution rewards their efforts in this kind of critical change area. However, the good news is that 94% are confident they can rapidly change their teaching. And I think that the whole COVID-19 thing has been a bit of a shot in the arm in that sense, because they've had to make change, as the Vice Chancellor from the University of New South Wales said the other day, that we made more change in 10 days than we might have done in 10 years, which I thought was a great line. So that's certainly a very positive outcome. So just wrapping up, really, the key in all of this development of bringing the SDGs and all our complex societal problems into our engineering curricula is about making change, and it's about helping students deal with complexity, and climate change is undoubtedly going to be the key challenge of the next 20 years. And how do we then build a systematic team-based process that will make that happen at each of our universities? And people like heads of schools and departments are absolutely critical in this process. And what we've found is students as partners are also absolutely key enablers. So I'm going to stop there and take questions or comments. Thank you. And I'll just stop sharing.
Great, thank you very much, Roger. So either raise a hand or feel free to ask in the chat line. I'm sure that will generate a number of questions. So Ron from Iron Range has started off. How can individualized learning integrate with this studio model?
Well, in the studio model, it is individualized learning, because the learning contract, for example, in data engineering, the students identify which part of the project they're going to contribute. So one person might be an electronics engineer who's working on the hardware design. Another one is a data engineer working on software. And in their learning contract specifies that component that they're working on, and the learning learning step up that they intend to engage in through that studio. So, and then they deliver evidence of that in the portfolio.
Okay. So how far along in the, I guess, mechanical engineering curriculum change process are you at this point? And would you say, what would you say have been the most significant challenges?
Just getting started, really. No, well, it's been a long conversation. It's taken us a couple of years to get to this point. Really a bit of fits and starts because, you know, people get distracted by other issues that are going on. So we had one meeting almost 18 months ago where we got the whole school together to reconsider, you know, how might we do this differently? We got somebody in from another university to kind of lead that process. And it's really just keeping the conversation rolling along. And also I think it's about helping people to realize this conversation isn't going to go away, that you know, that this change is going to happen. It is inevitable. And that's why having a head of school who constantly reminds everyone of how important this is. I think another critical factor in more recent times has been one of the senior academics basically having courage of the project, so that it's not me making change happen in mechanical, because after all, you know, I'm not a mechanical engineer, but that senior academic who is then attends all of our individual subdiscipline meetings, who is a connecting guy who you know, helps carry the story from one meeting to another. But it's, you know, I think it's also a lot of goodwill from academics to make that change. And I think until you get to that point of goodwill, you know, that's what you've got to get first, is you've got to get people, you know, who can see that this is going to be an advantage to them. And I think we had enough kind of early movers who could say, yeah, you know, we need to do some different kinds of things. Some of the things we're doing are a bit rubbish and they're kind of wasting students' time. And what we're not getting to is to have time to do the really interesting, you know, design and build type activities and so on.
Can I just ask a follow-up on that while we're there? Because I've seen sort of two models of changes. You know, what we did with the IEP was sort of a push for a change in a direction, and then sort of got a coalition of the willing, who are at least willing to change, if not willing to agree on actually what that change should really look like. Compared to, I've seen other programs where sort of the change is rather more mapped out to begin with. And it sounds like you're a bit more towards the second type of, there is a sort of map of the type of change, and you're sort of trying to bring people into it. Any comments on between those two approaches?
Yeah, I think we might have hoped for the first, but I think we tended to gravitate towards the second. And I think partly because data engineering was our first cab off the rank, and that was a new program set up in, I think they started in 2017. And they came up with this idea of, you know, that they would have three pairs of studios. They would have fundamental studios, application studios, and professional studios. So there'd be 6 altogether. Bookended by an introductory subject in semester 1 and a capstone in semester 8. And then electronic engineering followed the same pattern, and eventually electrical engineering tried to follow the same pattern with varying success. But mechanical, I think, did approach it a little bit more freely, but they've kind of gravitated eventually to the same attractor, which is, yeah, you know, this feels about right to have this amount of studio. We've played with the idea of whether you have single studios in each semester or whether you have a kind of double-sized studio every second semester. And there are advantages and disadvantages for both, as I'm sure you realize. Yeah, so in the end, it's good to have consistent stories, so you can say, oh, okay, why don't we do it like this? But I think it is a conversation that every institution needs to kind of figure out for itself. You know, if you go to Aalborg University, simply devoted 50% of their curriculum to project or studio. And it's worked extremely well for the last 45 odd years.
It's a good question from David here. So if the programs are student driven and the students are therefore the drivers, how do what's the academic role? Are they the navigators? How does that analogy play out?
Yeah, I'm not sure that the students are quite the drivers yet, but you know, certainly students, if we can make this work really well, the students, you know, take their own learning from one studio to the next through a continuous portfolio. I'm not convinced we've still got that working as well as it might. Where it's worked in summer studio is where students have come forward with the studio topics, and then we've put an academic with them to be their navigator, if you like, and to you know, really to help them understand how to go about it. And one of the interesting side effects, I mentioned the space group there. They were in our first summer studio, and it was quite fascinating because when they came to me, they said, you know, really interested in the space industry, and but there's all this content that the students will need before we get started. So we'll have to give them lectures on orbital mechanics and all sorts of other things. And I said, oh, don't do that. So it took a while for them to unlearn all the habits that they've learned, which is first dump a whole lot of content on students, and then you can do something useful with them. And I did actually have another slide that showed where students were prototyping an unfolding solar array for a satellite, which they'd come up with in this concept. And then it wasn't long after that we actually saw a satellite with really much the same folding solar array. So it was quite impressive.
So there is a question on that actually about the response you got from the faculty and administrators when you pitched the summer program.
Yeah, well, that's where the associate dean has kind of led through that process, and it was, you know, it was a way of getting the studio idea out there in front of everyone at a stage where only one of the disciplines had picked up the process. And as I said, it was not only a good time for students to understand the process, but it turned out to be a great time for the individual academics. So we had about 12 or 13 academic teams in each summer. So, and some of those in robotics, for example, have gone on to then change the way they were teaching their robotics subjects, which now look much more like studios. So it's about giving them the confidence that, oh, I could do this, because in summer they only had to deal with 15 or 20 students. But when they suddenly discover they've got 150 students, at least they know, well, I made it work in summer, so it can't be that hard. It's just about a bit of scaling.
I might bring David in actually, because there's a long question here, and it's probably easier if. But I think it is one that I'm asked a lot about how we coped with this. I think it's a very common issue. David.
Roger, thank you. This has been absolutely fascinating. The question I was posing was that driving the sorts of changes that you described and that we've made, the biggest pushback we often get is from people who say, oh, yes, that's all well and good. And yes, I accept that what you're doing will add enormous value and the students will learn great things and it's important, etc. But we won't be left with any room to teach X. So in other words, you get this deficit model that assumes that any change adds things but also takes things away, and that we can't afford to lose the things that are taken away. How do you deal with that?
Eventually you just have to give up X. But I think the process we've been going through with the mechanical program, because we've said to each subdiscipline, well, this is how much space you've got. And and we've kind of done a backwards design by saying, well, what are the kind of outcomes that you would expect somebody who, mechanical engineer who needs to know thermofluids, what are the kinds of things that they will do? They might design a pumping installation, or they might design, they might be an HVAC, so they can design heating and cooling for buildings. So, you know, tease out all those things. Oh, okay. So what might they be able to do at the end of a first subject in thermofluids? Right, okay, so that turns out to be mostly fluid mechanics and maybe we can get a bit of heat transfer in there as well. Right, what will the little project look like? So you kind of you work from that point of view. Now, eventually then somebody says, well, what's going to happen to subject X? You go, well, that could only be an elective. And it looks like it's a postgraduate topic, doesn't it? And students, after all, they do have 4 electives. And you could say you can still teach whatever it is. Or you can figure out how do you work X into the undergraduate curriculum in a small way. So computational fluid dynamics has come up and saying, oh, wow, that's a digital tool that students should know something about. Maybe they don't need a whole unit on it, but we could work it into a studio. So let's design a studio around computational fluid dynamics. I think, yeah, it's just about being creative.
I think one of the key things in that, I agree with everything you've said, Roger, I think that's right. I think one of the key things in that is taking colleagues on a journey about engaging with what their graduates are actually going to be doing. You know, so many academics see, you know, by our nature, academics are specialists, and they see, you know, one little slice of, you know, the graduate sort of role and see that as crucial. And so I think taking them on a journey about what the graduates are going to be doing and the sorts of problems they're going to have to manage, I think is really crucial in that.
Yeah, I think yeah, I had the similar thought recently where I thought, yes, academics are like medical specialists, but what we're producing are general practitioners. So we've got a bunch of medical specialists trying to produce general practitioners, and we should keep that in mind all the time, because, you know, most four-year graduates don't need that level of specialized knowledge. But by all means, let them explore that either. And studios are an opportunity for students to do a deep dive into a relatively narrow area. But not every student will do the same studio. So, and that's completely fine. And I think actually a lot of our research academics could really enjoy that process where they've only got 20 students in their studio tutorial, effectively.
Ria's asked a question here about, that follows on from that, I guess, about the sort of training for instructors. And, you know, I wonder if that's part of this process of actually getting people to see that this isn't just, what was it, one of my dear colleagues referred to it as just playtime for the students. There is actually something more to this process and to the learning.
Yes, well, we got much better at that. It's easy to imagine that everybody knows how to facilitate these kinds of experiences. And the first summer studio, it mostly went pretty well, but we had one or two studios where students got really angry because they felt as if that they'd been dumped in this thing and they weren't being given the answers. And so, and what I concluded was that students are not used to asking clarifying questions. They're used to getting an assignment sheet that is a perfect description of the task required with a submission date. And preferably for some of them, they don't actually want to talk to the teacher about it. And they'll submit it and all is well. But, you know, engineering doesn't work like that. You engage with clients tell you half the story. You need to go and ask clarifying questions, say, oh, exactly how important is it that it be yellow and well, whatever it happens to be. And students are just not used to that. So the next round of training, we kind of really worked on helping people to understand that process of leading students through, particularly the first few sessions where you're just uncovering the nature of the problem to be solved. So they then became much more engaged and much more about question asking rather than answer seeking. Yeah, so we learned a few things in that process.
There's a couple more. Interesting question about assessment. And again, I think that's something that often comes up from staff about, particularly where you have students exploring different things within an area. How to ensure that the assessment is fair.
Yeah, I sometimes say what we really want to do is switch from quality control to quality assurance. What you really want to do is manage a process where every group produces good work. And if these people were working for you in an office, that's exactly what you would want, is that by the deadline, there's a good submission ready to go out to the client. So that's the, if you like, the pass-fail criterion. What I think we're all hung up on is grading. So how do we separate a group who's done, yeah, it's kind of an adequate, satisfactory job, but it's not remarkable, from the group who have done really outstanding work that we're going to give a high distinction to. And then there are some groups in the middle. But what we find is that more and more of the groups actually are at the high end anyway. They're mostly getting distinctions and high distinctions because they get into it, they love the work. So it's less of an issue of the groups themselves. And then you have the individuals who, for whatever reason, give up, don't attend, disconnect. And that's where what we're doing is using some of those Agile tools to basically track the work that students are doing to help each of the group members to see what everybody's doing. So, things like Trello. So that there's some evidence collected. So that if there's a suspicion that one student is not doing much work, then there will be a lack of evidence of work on the Trello board. But again, I think it's trying to engineer that problem out as well, so that those students disconnect as early as possible if they go, oh, this looks like work. And that happens in Summer Studio. We often have about a 10% dropout in the first week or so because they go, oh, I thought this was a bit of a free ride. Oh, it means I've got to attend, I've got to do work. No, I'll just discontinue. And then the students who are left are really keen and working really hard and doing amazing work. And when we interview them at the end, they go, oh, it's the best subject I've done at the university. How can we do more of these?
So the question, would you say the studios were a bottom-up idea, or did the idea of studios come from the top, or was it more general, that was a specific, I guess, implementation of a more general direction?
Yeah, I think it was the middle level out. When I arrived at UTS in early 2016, I'd been playing with project-based learning for 25 years, and we'd started using the word studio in the couple of years I spent at Central Queensland, where Ewan and I never really quite got to work together. But when I came to UTS, there was already a software development studio running. Julia Pryor was running that, and Julia had done work in a national project on running studios, beyond the traditional design disciplines, which is where studios usually live. And so in that first year, we had these conversations around, okay, how do we distinguish studios from project-based learning? So that was one set of conversations. And then there was this other work that was happening at the same time around designing this new data engineering program, which had also picked up the idea of studios. And so it was kind of a coming together of minds, really, of several people. And that first 12 months of kind of refining the idea of what we were trying to achieve, and then how do we adapt a rather traditional approach to building engineering programs around this idea of studios, because UTS also has an engineering core. So there are eight subjects, 10 if you count the research method subject and the capstone as well, which every engineering student does. So when you design a new engineering program, you kind of start with some of the real estate already occupied. And so then if we add a bunch of studios in, you're left with relatively smaller amounts of space for what we think of as the technical subjects.
There's a couple of questions from Elizabeth. I'll bring her in to ask them. It's probably easiest. Elizabeth.
Thank you. I'm Elizabeth Pearson. I work at Purdue University, and we're looking at doing this with our curriculum, 800 students, so bigger scale. But so I apologize for pummeling all of the questions. It's fascinating. I noticed that you had internship on that the ME timeline there. So my question is does UTS, do they find the internships for the students, or are the students responsible for finding those internships on their own as part of their curriculum?
It's a bit half and half. So the university runs a career hub where we encourage employers to post intern opportunities, and then students also find their own internships through family connections and friends and so on. But then we have a scaffolded approach. So students actually do a 5-year degree. They basically do a 12-month, if you like, diploma of professional engineering practice together with their Bachelor of Engineering honours. So we have a preparation subject and a reflection subject around each internship, together with some online modules that they do while they're on internship.
Thank you.
I'll give the last question to my colleague, Emanuela, given that my UCL team are up in the middle of the night, and 800 is a good number, but I think, what's it, Fiona, now 1,128 we have this year?
Yes, 1,000 on my modules, 1,050 on
on the project module this year, yes. Anyway, Emanuela, over to you.
Hi, Roger.
Hi.
Thanks for a lovely presentation. My question is something that you said about trying to fit in topics into Studio if perhaps you can't fit them anywhere else. So the question that I have is really, has anybody realized yet that perhaps this Studio might be a better way of teaching some topics than perhaps a more traditional style lecture and labs? I mean, in the IEP, I think after a couple of years now, our projects are very much considered core, and taking them out is actually something that would be detrimental to both the accreditation of our programs, but also the technical learning of our students. So whereas before, I think, like John said, setting them up, people thought it was just a time for students to play. But now, the core knowledge and core learning is happening in very many of our projects. I just wonder whether or not there's that conversation now, because I feel like that conversation started about 2 or 3 years in with the IEP.
Yeah. If I had my way, every subject would be project-based. And it would be that mix of push and pull effectively, And one of the things I've shown the mechanical groups is the format model. And I don't know whether you all know the format model, but it's a kind of an adaptation of Kolb's learning cycle. And it basically says that we need to teach around the circle. But what the evidence is from looking at any of our classes is that we only teach the bottom half. The bottom half is theory building and skill application. So if you think of teaching fluid mechanics or solid mechanics or any of those things, we teach the theories, and we teach mass conservation, whatever it is, and we show them how to calculate flow on a pipe. And then, it's the end of the semester. There'll be a few questions on the exam. The students go away a bit bewildered, going, I don't know what this is for. If you teach around the circle, you actually start with the problem. Here are some typical problems a mechanical engineer faces, and which is why this semester we're going to do some fluid mechanics, and we need to know flow in a pipe. And we'll get there eventually. But then once we've learned that skill, let's go and do something useful with it. Let's design a little mini project where flow in a pipe matters. So you can do these, you know, what I think of as half-half type subjects where you're building the theoretical underpinnings, but you're doing it in a practical context. You know, and I'm sure many of you have had that experience. And that's how I used to teach computing subject. But just that notion changes the whole way that you'll teach that subject eventually. And that's what we discovered early on when I was back at Monash Uni. You know, I said to all my colleagues, why don't you just put a little project in every subject? And they all nodded at me and said, that can't be too hard. And then it was only a few weeks later, and they started coming back to me and going, you know, if we do that, we should change the order in which we teach the concepts. And I went, wow, what a good idea. And in the process, we changed the way we taught civil engineering. And it's still, you know, rather teacher directed in one sense, but the projects just changed the way students engage with it. There was no doubt about that. And the studios are just trying to take it one step further of, you know, giving students bigger open-ended tasks to do.
Great, thank you very much. So thank you very much, Roger. That was a very interesting talk, and I think some really interesting questions. I think they are you know, things that play on the mind of anyone who's thinking of doing this. And I think I've heard a lot of the questions, and you hear a variety of answers. So very good, very, very interesting to hear your take on how these things play out from your experience.